All right, we are back and we are working on our programming language called Tang. And yes, in this series, we are creating a programming language from scratch. And yeah, we're in the middle of getting all the basic pieces together. The last video that we did, we had created our garbage collected object class. It's a container that would do reference counting. And yes, I know that I should have probably said this when I did that episode. I know that it's not if you have a cycle, right? One object referencing another, and then that references the first one. It's not going to be able to garbage collect that. There are algorithms to help with that, but we're not implementing those. This is simpler than that. So, where does that put us? Well, last time we got to a place where it was working and we had tests that worked. And then as I was looking at starting this next series, this next step, I realized I have a problem. And that is, let me just show you. So we are, I guess I'm not focused on the right window. I'm going to open the test garbage collected. There we go. And let's just look at one of these. Garbage collected, sure, this line right here. Notice we create this object G1, this garbage collected container. And it's wrapping around some computed expression integer. And it works just fine. And G3, by the way, happens to be another garbage collected value of computed expression integer. And the point of the computed expressions is that we want to be able to have these different types of things. Different types of computed expressions. There will be a computed expression integer, a computed expression string, computed expression float, computed expression boolean, computed expression array, and actually quite a few computed expressions. And, well, that's fine, but the point of it, or what we need to realize, though, is that a garbage collected computed expression integer, which is what you see on the screen here, that line that's highlighted, is a different type than a garbage collected and then in brackets computed expression float, for example. They are fundamentally different types, and you, at least as the compiler sees it. And that's a problem. Why? Because our virtual machine needs to just think, oh, I've got something that's garbage collected, not something that's garbage collected and it's an integer. And that's a problem. So how we define this, we need to fix. And so let's just go into this. I need to edit source / what is it? Garbage collected. Not source, include garbage collected. Let's see how we can fix this. First of all, I don't want the template, the class, to be templated. That's the first thing. Well, I can already tell you, we're going to have to specialize a little bit. This isn't just something that's garbage collected. It is a computed expression. We've got to standardize on that. It is a computed expression. So I'm going to pound include computed expression. Now, we're going to get rid of this template class T. And now everywhere where we see the T, well, except in, we'll talk about this constructor in a moment. But down here in our types, there we go. This is going to be a computed expression. This also is going to be a computed expression. Okay. And then this is going to be a computed expression. Simple change. Now, we want to make the constructor, the default constructor, we want it to be private. All right, so I'm going to make a copy of it here and go down to where our private stuff is declared. Here we go, and just put it right there. Plop it in. And now we'll just say it is private so that a garbage collected object can only be created using the make function. You say, what is the make function? We haven't created it yet. Okay, but we're going to right now. And it doesn't need any of the templating. We're not going to give it a lot of different parts. In fact, what we're going to do is we're going to say count will be 0 and ref is null pointer, and there we go. All right. Now we're going to go back up, and this garbage collected, the constructor, we're going to do two things. Number one, I'm going to add a class of T here, and then all of the variable stuff. It's going to now be something, it returns garbage collected. It will be make, and it will be static. Okay, so what does that mean? That means we're going to be able to call this, say garbage collected :make, and tell it what we're going to make, and then pass in the arguments. Yeah, that's how we're going to do this. And now, we need an object to put the stuff in. So let's make garbage collected GC. So that is just, it's a local variable. And we're going to say gc.ref is equal to new, and we're creating it from the object pool. That's just fine. And the count is 1, right? And it's a pointer. That's fine. And now we need to return GC. Now that's almost all that we need to do. The problem is the destructor. Let's look and see what the destructor does. It calls this singleton object pool T. And because garbage collect GarbageCollected itself is not a templated class. We can't do anything with it. That is, we can't use T. We can't use a template. So the only time we know what this type should be is up here when we, in our make function. So we're going to have to do a little bit of trickery to get this going. We're going to use a lambda function. Of course, a lambda, an anonymous function. I don't even know when this came about. Can I find this really quickly? C++11. In other words, it didn't exist when I started programming first, but all right. And this is going to be, we need a member function or a member variable, and it's going to be a cleanup function to recycle the object. And I believe, let's just call this, first of all, this is a standard function, and we'll just call this recycle. Oh wait, we can't leave that bare. We have to tell it, you know, kind of what's the, it itself is a template, but thankfully all that we have to do is we have to say, the type, is that right? I'm thinking out loud. Yeah, well, the return type void, and let's say right now we're not going to give it anything. It's just going to know what to do. Yeah. So it's called recycle. Now, to the make. And I'm going to say this, creates a garbage collected object of the specified type. Param, now it returns something. So let's say return a sure. Okay. Oh, and I was going to look and see how to do variable arguments in Doxygen. Haven't done that yet. We will. All right, so we need to create this. Let's gc.recycle is equal to, and all of these symbols. What is it? First of all, we have to say, what do we capture? What does this need in order to be able to do its job? And let's do temp. And it is a memory address, so we're fine there. We don't pass in anything, but now what do we do once we're inside of it? We're going to say singleton object pool of type T, get instance dot recycle. And what are we going to recycle? Temp. Is that right? Yes, it is. So we are creating a function, and at this point I should probably make sure that this actually compiles. Oh, it's not going to because we had to put this in the garbage collector. Not the garbage collector, in the destructor. That's what I meant. That's what I meant to say. Yeah, yeah. Where's the destructor? Right here. We're gonna say this recycle. And we need to, in all of the different ones, so I'm just going up the top, right? We've got 4 other things. Our copy constructor, we need this recycle is equal to other dot recycle. This is the moving. The copy, that will copy, that's fine. But in this case, we can might be slightly more efficient. Okay, so copy assignment, it needs to be a copy, and so we'll say recycle is equal to other dot recycle, and then lastly the move assignment will do the same trick. We'll say this recycle is equal to standard move other dot recycle. There we go. Now it should all compile. Let's find out. By the way, our tests are no longer going to work. I already know that. But I just want to see if it gets through the compilation step. Or, well, yeah. If it gives me any errors here, or if it gives me errors in the, when it tries to compile the test. That's where I'm expecting the errors to be. So make, is it test or watch dash test? All right. And the errors are, they are legion. Let's see. It's not a template, so it's messing up in the test file. That is good. That is very good because that's where I expected it to be. Now, let's fix this. So garbage collected, what we're going to say, we'll say auto G is equal to garbage collected : make three. That should work, and if this is correct, then this first, what we've got right here is, yeah, we've got an errors on line 9. That should disappear. Now the next one's probably going to show up on line 15, but that's what I'm expecting. The one for 9 to disappear, and then it show up on line 15. Up to the top. Yep. 9 is gone now. 15. So we just need to change how all of these are working. So this is going to be auto G1 is equal to garbage collected make What are we making? Auto G2 from G1, that should be fine. This one, P null pointer, garbage. All right. And I guess the good news is we're almost done. All right, now, what does it not like? Line 26. I was afraid of this. Okay. It doesn't know how to convert from a computed expression pointer to a computed expression integer pointer. And so P is a computed expression integer. And you know what? The easiest thing to do would be to do that. And now 37. Same thing here. And it works. And this is the beauty of unit testing. We refactored something and we know that everything that we tested about the order of, you know, does it recycle things correctly, and when things are going out of scope, we know that that's working. So we know that it's calling that lambda expression that we created and all of that, and it's working. Yay. Okay, so I'm going to quit, and I'm going to say, because I'm going to go ahead and save it at this point. I mean, I'm going to commit, make a commit at this point. All of this looks good. And I'm going to say git add include garbage collected. I should have just done that in one command. Oh well, git add test and git commit dash m refactor collected to not be templated. Yeah. All right. Next step. So we know now that we want to rework the way that our program executes. So let's look at the program. This is includes program.hpp. Yeah. And the program, when we execute, looking for that. Oh, it doesn't do anything. Okay. Oh, but I already know what we need. We need up here to pound include garbage collected and no errors yet. And so private, let's see, code type, AST, error is a pointer, bytecode. Ah, this is garbage collected. So the result is garbage collected. That's the first thing. Now I'm going to save this, and not enough stuff recompiled. So yeah. Well, we'll get there. I'll do a make clean and then recompile everything. I do want to go ahead and open, since I opened the program, and actually, so this is result. So let's look for result right here. And it is not garbage collected. There we go. That's the only two. Okay, now let's open the source/program.cpp. And now I've got the same thing. So if we look for the word result, we don't need to delete it anymore because it's garbage collected. So that's fine. Result, this is the oh, so that was our destructor. This is our copy constructor. Oh, well, we can, yeah, just make a copy. We're fine there. All right. That's fine. Where's result? There we go. We don't need to clean it up because it will clean up after itself. We just and now that's our copy. Swapping is fine. Get result. We're going to garbage collected, and it's going to return result, or the optional garbage collected. Next. So our stack, okay. Now, so our stack is no longer a computed expression. It must be garbage collected. And now, so when we push back, it's not a new a computed expression integer. Rather, it's going to be garbage collected make a computed expression. Nope, that was wrong. Computed expression integer, and we feed it what we were feeding it before, and that will make a garbage collected value. And so then when we do the result is equal to stack back, that is fine. Okay, so 189, we can't delete this because it's not a pointer. In fact, do we need to delete the stack? No, because the stack, what is it? This, it's a vector, so vector, and I want to just empty it. And it may just be empty. No, that checks. So clears the contents. Okay. So we'll say stack.clear. Did I even have to do that? Because the program isn't going away. It just, we're removing the stack contents and putting, yeah. And it won't delete result because it's garbage collected, so there's a reference to it. That does it now. To int64t. It doesn't like it program 170. Oh, okay. So it doesn't like the fact that our bytecode is that. So we can do, just tell it that it's supposed to be an int64t. Does it not like that? Doesn't like something. Oh wait, I want to. Just because I want to recompile it from scratch. And now let's see. Running along through here, it says this may be used uninitialized. This, and it's not going to be used uninitialized, but we had to fix this before. How did we do it? I don't remember, but that's fine. All right, so I believe where my problem is my move constructor. I don't need to call it garbage collected because it's uninitialized. That's what the warning is. Now what will the move constructor look like? So it's running on, I mean, this is uninitialized. So I'm setting ref to be the other ref, the count to be the other count, increase the count, and then I'm moving recycle. Yes. And it works. All right. And all of our previous tests from the beginning work. That was a lot of fiddling around for me to just realize I'd made a stupid mistake. You don't have to call the destructor in the constructor. The constructor is only for the initialize. In my mind, I was evidently thinking about this the move assignment operator. In which case, yes, we do need to call the garbage collected and replace everything. All right, now on to the next step. We want to look at, so our buffers are, so don't think we need to do any more work in garbage collected. So let's do B3 and delete that buffer. Now, so we've got program, that's fine. And let's open the test. Yes, okay. I don't want all of this pool stuff there because we're not needing to do it. Let's go back to where we just have the program and the program execute. We're getting there's the AST. That's fine. Okay, just making sure of where I am. Got rid of a lot of stuff. And now what I want to do is to say so the program is executed. And of course, result, program.getResult. Arrow dump. Oh, I haven't done the pound include. gtest / and I learned this last time, gtest.h. Uh-oh. I mean, this will compile just fine. But my uh-oh was, I need more stuff here. There we go. And on 4. Oh, because it wants me to write it. There's something I can do that will all right, now it's going to say there's no tests. That's fine. But test. And what is this first one going to be? It's going to be, we're going to be testing I'll come up with a better name later. So what we're going to say is we're using namespace Tang. So I will say auto p1 is equal to Tang base script 3. That's all. Dot execute. Oh, I'm going to I don't need the singleton object pool. What I'm trying to do is I want to do p1 dot get result, and I'll cover what CE is in just a moment. Nope, I don't want to do it that way. So we'll just say garbage collected no. Just going to say 3. It's going to complain because it doesn't know what to do with this, but that's all right. What we're going to do and it's just saying it doesn't know what to do with the operator equal. So we need to provide an operator equal. Well, I mean, I could scroll up far enough, but yeah, it's just looking for something to do. Doesn't know what to do with operator equal. Okay, so buffer. What we have, so get results is a it's an optional. So it should be that. Okay, that's better. So now it's a garbage collected on one side and something on the other. So I need to go back to garbage collected. Garbage collected it's buffer 5. Nope. That's the test for garbage collected. We need to open it. Control E, colon E, whatever. Include garbage collected. Now, there's a couple things we need to do. So bool, and we can say operator equals, and for this, we're going to pass this off. So template will this work? I haven't, again, I don't do templates normally. And what I want to do is I want to say return this ref compare. No, I'm going to say is equal. Val okay. Actually, instead of a type def, I might just be able to use an auto. Of course, I don't need T. So this should be, let's put the ampersand there. And now it says, hey, I don't know what to do with is equal. Good. But we're passing this off to the computed expression. So let's go into our include computed expression.hpp. All right. And we are going to all right. And let's do this as a virtual bool is equal with an auto val const, and then for computed expression integer, we'll put it there and override. And so computed expression, make copy and let's also do this here. We'll say bool and up here we needed a const and oh yeah, I want this to and all right, now let's see what it doesn't like. First of all, implicit templates may not be virtual. Yeah, I didn't like that. Okay. Fine. Is equal and going to give it an int. Int and so it's only going to work with ints, but we'll have to add each type. That's fine. Means I can get rid of that. It's a constant. Okay. Uh, and we'll do these. Constant, constant. All right, so garbage collected and constant. So let's look at garbage collected again. Yeah, that'll do it. I needed to have a double equal there. All right, so watch test. Okay, so now I'm getting a segmentation fault. That's fine. You say that's fine? Yes, it is. Because we're closer than we were. So 4. It's probably in this. Why did it not like chaining execute? It should have. By the way, it works. We could have a... Oh, yay, it works. But why did it not work when it's chained? So let's see. Program dot execute, and it returns a reference to program. Where's execute? That's what I would expect it to be. And now back to 4. This will give me sometimes when I get weird results, nope, still getting it. Okay, so still doesn't like it. Not sure why. I'm wondering if I can do this. That works. It just doesn't like it when maybe something's up with the copy assignment operator. That's the only thing I can think of. Anyway. We can have a 2. And instead of a 3, let's replace this with a 42. Why not? And that works. And let's try to do one other thing. Let's see if we can support a minus. How do we do that? Oh, I'm glad you asked. We need to edit flex. Haven't been in here in a while. And what we're looking for is, you see, I don't know if you've looked at this. I added a whole lot of help text and links to describe all the stuff. But what we're looking for is right here, this initial script. And we want a... You know what? That didn't give me any errors, did it? it says okay, well, there's two things I want to check. First of all, I'm removing the negative 42. And, okay, so it says it doesn't, it failed something. Okay, that's good, but I don't know what it is. And so we need to teach GoogleTest how to I have a page here, how to print our values, and there's a link. And all that we need to do is it needs to be friend so that it picks it up. But, it's just the O stream. That makes sense. So let's do that. Do I still have garbage collector open? Yes, I do. And so we're going to let me double check this. Yeah. Oh. The output stream and then param garbage collected value, and then return the output stream. And this must be declared as a friend, or it doesn't pick it up, or that may only have to deal with polymorphism issues, but that's okay. Operator, the insertion operator or the shift left operator, and this is going to be we need to say its return type, and that is a standard OStream ampersand, and its input is a standard OStream ampersand, and we're calling this output, and a const garbage collected ampersand GC. And what do? If GC dot ref can I do this with the ternary? I would much rather. Return out GC dot ref. If it's there, then do GC dot ref dump, else it may not like it since that's a C string. There we go. I have not added this garbage collected, so when I changed it, it didn't know which files to rebuild. So I just made clean, did make clean so that it deleted everything, and now it picks it up. And see, it says it's Negative 42, that's what's in garbage collected. And I said I was expecting 42. So go back to the test, which is number 4. And B4. And I change this now to a negative. And we now support negative integers as well. Happy about that. Okay, we've gone on long enough. Let's wrap this up. We've got our garbage collection now working with our virtual machine, and we've made the stuff a little nicer. We've cleaned up our main test, and the main test is what we're going to start using to start coming up with these different types. Yeah, that's what I'm trying to say. Okay, so get status. Oh boy, there's a lot. Get diff. Just looking to make sure that I've got it all cleaned up. That is it. Okay. I can do a few things like git add flex Tang scanner and git commit add support for negative integers. And by the way, I should probably at least point out what I did. I added a minus, which as long as it's the first character in the pattern, it's a literal. And a question mark means see it 0 or 1 times. In other words, it could either be there or it doesn't have to be there. And so if it's not there, it just skips over it. If it is there, it incorporates it. So simple enough. And computed expression include garbage, include program, source computed, source program, and test.ts.test. And should be everything. I could have said git commit -a, but I prefer to spell everything out. And this is garbage collected. All right. Now, last few things I'm going to do is docs-pdf, and I'll show you something. So, multiply define. That looks good. Let's make sure that these are all untracked and modified. Yes. Update the documentation for episode 11. Now, the last thing I want to do is I should have this here. Yeah. Refresh it so that we've got the latest. And I want to go to the file list. Specifically, if I look up, well, the make file, and let's just say Tang parser, Tang scanner, the object file, ast.o. Right now we're saying it only relies on ast.cpp. I should be able to see here that it does rely on ast.cpp, but it also relies on macros and opcode. Okay? So macros and opcode macros, that would be include macros.hpp and include opcode.hpp. And if I look down, are there any others? Program.hpp. So let's do and GarbageCollected.hpp. Oh, that should have been error.hpp. Singleton object pool. And then location. You say, that's a lot. It's everything. Yeah. And if you change any one of that, any one of those files, ast.o needs to be recompiled. And so now I am really quickly going to go through each of these. So computed expression and .cpp. Is that right? It only relies on computed expression.hpp? Yeah, it only relies on those. Now, other things rely on it, but it only relies on that. Okay. The next one, error.cpp. Does it rely on anything? Just the HPP and location, and we've got those. Let's move down, shall we? We just did error. Now let's look at program. Program.cpp. It's going to be a big one. All right, that's fine. It somehow I didn't get include program.hpp. Should have had that at least. But Tang scanner. Yeah. What else? Opcode. AST. Error. HPP, and the last one is gender location .hh. All right, almost done. Tang base. It's got several. And somebody may have a better way of doing this then. If you have a suggestion, open a merge request. I'm happy to indulge. All right, and for Tang parser.o, that is, oh, it's in the generated. Okay, that's fine. And Tang scanner, that's also in the generated. It didn't like my spelling. I don't blame it. INCDCLDUE. CL. It's faster, just delete it all and. Okay. And again, to make sure, make clean, make test. Everything compiles. We've got all of our tests passing, including our integer test. So now don't want to do that. Did we only have to do 3 of them? I guess so. Okay. And with that, you know, I'm always curious. Make clock. Lines of code went down? Okay. I can handle that. That's fine. With that, we've come to the end. We've got in fact, do I have this here handy? Yep. Here's our website. The GitLab location, and I did add in GoogleTest. I don't remember if I had mentioned that in a previous one, and we're still nowhere near being able to like do our Fibonacci sequence, but it's coming. It's coming, and at least our tags, it should be, yep, episode 11 is there. So if you've lasted this long, thank you. And next time, definitely, we're going to add floats, and we'll see if we can add addition. that would be good. That would be a good first step to add addition. We can even do addition before integers, but I'd kind of like to do that. We'll see. It's both each step. It takes more time than you think, but it's also going to get faster than it has been. It's taken us 11 episodes to get this far. The speed will increase. All right. Thank you. And hey, I hope it's been fun. Have a great day.